Hey folks, Larry here. I just want to explain what I've been working on recently, which is this game slash platform for learning deep technical fundamentals and exploring worlds. I'll start by talking about the vision, and then I'll share what's been built so far. The vision is that first there's going to be learning materials that'll teach you the technical stuff rigorously, so like logic, programming, formal math, algorithms, etc. And these will be like interactive. Bite-sized snippets of knowledge with exercises. You complete these, and you earn materials that you'll use to unlock the worlds. The worlds will be actual game worlds where you use your knowledge to build tools that will enable you to progress. And the worlds will start simple and become gradually become more complex. A simple world, for example, might have you program up some sort of navigation module that will allow you to access new areas and uncover secrets. A more complex world would be like, say, you got to use your knowledge of physics, operating systems, algorithms, etc., to build battleships to fight enemies. And you control these battleships, you maneuver them. How they maneuver is going to depend on your programming. But as you progress, you'll unlock upgrades that'll power up your ships. And sometimes you might have to build integrations to incorporate these upgrades. It's basically an RPG where the main character is also an engineer. If you played a game like say Armored Core 6, which by the way is an incredible game. I'm a huge fan of FromSoft games, but if you played Armored Core 6, they kind of just give you the mechs. But what if you had to build the mechs out yourself from first principles using everything you learned, and then you take them into combat? I think that would be pretty cool. The game loop is essentially do these learning snippets, acquire knowledge, acquire materials, explore worlds, repeat. Before I continue, I have to put a disclaimer, which is this is just the vision. What I have today is not really close because I just started building, and building games is time consuming. Even with AI, I am kind of tired of modern gamified, in quotes, education, which often is just multiple choice questions and music and leaderboards. And the questions are not really that deep. That they're pretty shallow. They don't really teach you much. And the music and leaderboards is just there to get you hooked. But gamification, if done correctly, is extremely useful. It'll enable you to see patterns, connections between things, map what you've learned to new contexts, which, by the way, is the true test of understanding. When I was in elementary school, I played this game called Maple Story. I spent a lot of time in the free market making trades because I had to make money to um to buy gear to fight the bosses. But I was building some pretty big spreadsheets and analyzing profitability. I learned a ton about arithmetic, about economics. In fact, this was the experience that solidified my understanding in those because, frankly, my elementary school teachers were not very good. At least that's how I remembered it. Then, when it came to the boss fights, there's a lot of teamwork involved. You couldn't just solo them because they were too complicated. Everyone had to do their part. If one person messed up, well, the run's over. So there were lots of mechanics that you had to know and understand. Everybody had to know and understand these. Um, and actually, oftentimes, before you can even fight the boss, you had to go through a series of difficulties, like jumping challenges. Maple Story is notorious for its rage-inducing jump quest, so you had to plan for those. It was just a lot of planning and reading and communicating. In fact, this is actually how I got better at reading and communicating. But these were just the basics. They weren't really that technical. There isn't a game today that'll teach you the deep technical fundamentals while also being a game. So I think there's a huge opportunity here. Anyways, I've been talking a lot about the side stuff, but let's actually jump into what's been built so far. All right, this is the select screen for an introduction to Python sequence, part one. The first big milestone is to get everything from my software engineering roadmap on here with the complementary worlds. I'm going to start with Python, then move on to logic, then algorithms, then the other stuff. The Python sequence will be broken down into either 3 or 4 parts. Haven't quite decided that yet. And these are the worlds for part one up here. Um, Now I don't have these fully modeled yet, so unfortunately I can't show them. But I'll talk about the direction. Actually, I'll talk about these later. There's also a shop right here. You can buy items. I'll also talk about these items a bit later. But let me just buy these real quick though. The stuff Down below are the learning materials. So this forms a bit of a constellation here. I'm just gonna jump into this one. If statements. So the content, yeah. So the content is going to appear bit by bit, so it doesn't overwhelm you. You can run the code, give it some inputs, run it again. Let's give it -5 this time. You can also modify this code a little bit. So this one, let's delete this, and let's run it -5. It's not gonna. It's gonna print one less line. Um, so yeah, there's a design principle that I really believe in called progressive disclosure of complexity, where you just reveal information one step at a time. You don't throw everything in all at once and hope people understand. That never works. So the content's going to fade in. One of the common mistakes I see people make when learning technical stuff is that they don't take the time to truly understand before moving on to the next thing, but they move on and they have no idea what's happening. Eventually, they get to the exercise and they can't do any of them. They get demotivated and give up. So here, I'm just going to present things bit by bit. In order to proceed, you got to make a conscious effort to click this down arrow right here. I might add more gating in the future, not sure yet, to be determined, but let's continue. So you read this, you try to understand, and then you read this, you try to understand, you take some notes, whatever you got to do. Let's continue. Uh, continue. Um, and then there's going to be exercises. Um, so a big problem with pretty much every technical book I've seen is that they don't show the exercises until you go through the entire chapter. But a lot of the exercises don't require everything in that chapter. They might only need you to know like the first idea. So I'm going to present the exercises immediately after an idea. Also, a lot of times, subsequent ideas build off the previous one. So you really have to have that understanding before you move on. Doing exercises is the best way to develop that. So these exercises will be interactive. Let me just find the solution to this real quick. All right, there it is. Let's hit the submit, and there's the congratulations UI. Here's some materials for completing it. You can see it right here. But let's continue. There's another exercise. Let me paste the solution real quick and hit submit. And there we go. Continue. Um, and we are done. One thing I was going back and forth on was animations. Animations are extremely helpful, but only if presented in the right way. Otherwise, it'll add a lot of unnecessary cognitive load. For the first part of this Python sequence, I don't think I'm going to include any animations because I feel like this stuff is fairly intuitive. And it's a great exercise to map text to images on your own. Extracting out pictures it's a great way to cultivate understanding. That's another reason why you got to be careful with animation so you don't rob the learner of that opportunity. Now, for this Python sequence, I want to show people how to think about programs, how to think about structures, mental models, just generally how to think in this domain. But at the same time, I don't want to tell people everything. I want to nudge them in the right direction so that they can figure it out themselves. There's too many books. I feel like there's too many books and courses out there that just tell you everything, but you learn a lot more figuring it out on your own. So this sequence will be exercise heavy. The exercises will, I guess you could say, nudge the understanding. But I also want to go deep, reveal the right intuitions, the right thought processes. In particular, I want the later parts of this Python sequence to demystify how programming languages work under the hood. I'll probably have a few projects where you code up an assembler, write some assembly, and maybe even make a simple compiler. But the complexity does have to be balanced since this is just an introduction. So yeah, I mean, there's a lot that I'm thinking about right now. But let's head back to the select screen. I'm still deciding whether to break the sequence down into 3 or 4 parts. Part 1 is just the basics that you see here, so variables, operators, statements, loops, and stuff like that. Part 2 is going to be functions and references, maybe classes and modules. I'm not sure if I should split classes and modules into another part, but there's a lot to be explained here. It can't just be like, here's how you write a function, here's some examples, go wild. All the right intuitions have to be revealed. So how to think in terms of interfaces, program structure, dependencies, maybe even design principles before you start coding stuff up. This is the thing. These are things that introductory programming materials often gloss over, but it's crucial that you know these in order to have a strong understanding. It's also crucial if you want to be a software engineer. So there's lots. Um, Lots of discussions to be had here. The last part will be recursion. This topic is it's like a brick wall. It takes a lot of practice. You gotta see. You gotta see it from a bunch of different perspectives to really understand. You shouldn't go into this without having significant exposure to programming. That's where the worlds come in. Or I guess if you did a lot of math and you really understand induction, you can jump right in. But yeah, after Python, I'm gonna work on logic and basic formal math. It'll be like how to prove it. I'll make a video once that's fleshed out a bit more. Now, I think recursion should always be discussed in or alongside trees. Trees are very intuitive, and there's a lot of practical use cases for them. Trees naturally lead to parsing because every program is essentially an abstract syntax tree, AST. So in this part, I want to explain the recursive descent algorithm for parsing programs into ASTs. Once you have the AST, you pretty much have an interpreter. I really want that to be one of the projects, but we'll see. It might be a bit too complex. We'll see. Now, unlike the other online learning platforms, this one's going to go deep. It'll be rigorous. All the important details will be discussed with worlds to explore, just to break up the monotony. But unlike books, the material will be broken down into bite-sized pieces. Not going to throw walls of text at you, and it's also not going to have you go through like a million pages of theory up front before you get to the practical. Actually, a lot of time books don't even have the practical stuff. So one of the major criticisms of modern learning materials is that either they're too dense and theory pilled, or they're too basic. Pretty much every online learning platform nowadays is too basic, and every book is like an inscrutable wall of text. I think these are valid criticisms, but in reality, you don't need a lot of theory to start building cool stuff. Like I always recommend the book How to Prove It for folks who want to get started in a computer sciencey field, and that book turns a lot of people off because it's 400 pages of formal math, hardcore formal math. But even after the first 2 or 3 chapters, you can start applying your knowledge by, I don't know, say building basic hardware components like half adders, full adders, multiplexers, SR latches. These are just glorified truth tables after all. And you can compose these into more sophisticated stuff like registers, arithmetic logic units, CPUs, RAM. At that point, you pretty much have a computer, a very simple computer, but still a computer, and you should be able to explore worlds with it. You should be able to do stuff with it, and you should be empowered to jump around. You don't have to read 400 pages of formal math all in one go. Although I guess if you really wanted to, you could. But jumping around is how you see the connections between things, and that's crucial. Speaking of worlds, let's go back to these up here. You can see there's a to do. I'm still working on that. Let me just unlock this real quick. But I'm still working on it. I took a lot of inspiration from idle and automation games. Actually, let me just pull out a picture. It's kind of like, I guess you could say it's like concept art. The worlds are going to be something like this. It's going to look like this. The art style is probably going to differ. I got to put another disclaimer, which is that I'm not that great at art. I've spent most of my career looking at screens of black and white text, so terminals, stack traces, logs, etc. There's a lot for me to learn here, and I am trying to improve my art skills. So yeah, but there's a platform and objects you can interact with. The goal is to have you program up automations to earn points, so maybe like an automated like miner or something. You complete the world once you get a certain amount of points. It won't be too complicated since this is just part 1 of an introduction. I don't want to overload people, but the worlds in the later parts will get bigger. One of them I'm considering is you build a factory, you fulfill orders to unlock materials that'll enable your machines to get better, and you got to program up the machines. The world is cleared once the factory gets big enough. Yeah, so something like that. I'm gonna have to play around with these ideas. So yeah. Let's go back to the shop. So this stuff in the shop will be used to unlock what I call dedicated worlds. I'm not sure if that's the right term, but these are standalone worlds. It won't be like they're not going to be like these up here. They're not going to introduce new concepts or teach you necessarily. Instead, they're going to assume you already understand the stuff and throw a bunch of complexity at you all at once. So these would be like the world I mentioned in the beginning, where you use your understanding of physics, operating systems, algorithms, etc., to build battleships, just like fully fleshed out environments to really challenge you. Complex, sophisticated, real gamification, not like the modern apps that exist today, but real gamification. And there's this quote that I really like, which is, "Give a man a fish, feed him for a day. Teach a man to fish, feed him for a lifetime. But what if you set up an environment where people are empowered to discover fishing on their own. I think that would be incredible. But yeah, this is what I'm going for. There's quite a bit to build. The road ahead is long. There's this other quote that I really like: "Dream big, start small, act now," and that's exactly what I'm gonna do. So that's exactly what I'm gonna do, and I'm gonna work on this for the foreseeable future. So yeah. All right, that's it for this video. I'll put out more of these in the future as things develop. If you're interested in tech, you want to chat, please join my Discord. Links in the description below. And I will see you next time.